In this tutorial, we will be discussing the pH scale. The pH scale is just a range in which we determine if it's an acid or if it's a base, and it ranges from 0 to 14. Halfway through that is 7, which is why we get a neutral value of 7. If it's less than 7, it's going to be considered an acid. If it's greater than 7, it's going to be considered a base. So there's a couple different ways to determine the pH of a substance. One is through a pH meter, like this. Another one is through pH paper or litmus paper. And another one's through an indicator that actually changes color under different pH levels. So here are just some common things to compare it to. For instance, your stomach is 1.6, so it's very acidic. A carbonated beverage is actually 3.0, so it's considered acid too, which is why the dentist typically tells you not to drink too much soda. Coffee is a little less acidic, which is why they said that if you need caffeine, go to coffee rather than soda. Neutral is pure water. Notice this, seawater is actually more basic than neutral water, than regular water. That's because of the salt in it. Bleach would be 12.0. It's very basic. So those are just a few common things that you might be used to. So how exactly do we determine what a pH of a substance is? Well, it actually corresponds to the amount of hydrogen you have in there, which is why it's called pH. The H relates over to hydrogen. Hydrogen is so tiny, it typically doesn't exist on its own, so therefore it has a tendency to bond to water to make H3O, and so since the H3O is more common, we've started using this abbreviation instead. But pH is just a little bit easier, there's less to write, so they just kept it as pH. But either way, you're looking at the concentration of hydrogen. You're actually doing a mathematical equation of log. If you look on your calculator, you will see a button that says log. And that would be the number that you're going to use. That's going to be the button that you're going to push when you type in your concentrations. Remember when you type in times 10, if something's times 10 to negative 5, times 10 to negative 2, don't put in times 10. Put in EXP or EE. For significant figures, however many significant figures you have in the concentration is how many spaces you're going to go past the decimal. Alright, so let's do a practice. This is aspirin. Aspirin is considered acidic. That's why doctors tell you not to take too much of it because it will upset your stomach, or that's why you sometimes get an upset stomach when you do take aspirin. But let's say that the aspirin has a solution, and a solution has a H3O plus concentration of 1.7 times 10 to the negative 3. That means to type this in, 1.7 times 10 to the negative 3. You're going to type 1.7 times 10 to the negative 3 in first, so it would be 1.7 EE negative 3, 1.7 EXP negative 3. Then you're going to hit the log button, and that's going to come out to be negative 2.77. That's where this negative sign comes in. You're actually going to change this over to a positive. So your final answer is 2.77. Let's try another one. pH of a solution with a H3O plus of 4.0 times 10 to the negative 5. So negative log 4.0 times 10 to the negative 5. So put this in your calculator. 4.0 EE negative 5. Push the log button, and then you push that negative sign, and it becomes 4.40. Notice in both scenarios, they gave you H3O plus, because remember, pH is derived from H3O. So if they happen to give you an OH minus here, This is important. If they give you OH minus, you have to go back, figure out the concentration of H3O plus, and then figure out the pH. Keep that in mind. That's one way that a lot of early students get tricked. So we can actually reverse this by determining the concentration of H3O given the pH. There's actually a button on your calculator, sometimes it's a second function of the log, that says 10 to the x. That is reversing that log function. So to do this, we have 3.0 as the log, as the pH. First thing you want to do is make it negative 3.0, because remember that negative sign of negative log pH, negative log of the H3O concentration. So the first thing you want to do is make that negative. And then you're going to do 10 to the x. Push that button. And it will come out to be 0.0010. Chances are I won't see that 0 at the very end, but you know you need it because of here, because of the significant figures. We can actually do that again. So 3.42 becomes negative 3.42. And then 10 to the x button, and that equals 3.8 times 10 to the negative 4. So here's the relationship between pH and the H3O plus concentration and the OH minus concentration. As the concentration of the H3O is high, your pH is going to be low, and that means it's more acidic. It's actually inversely proportionate. For instance, this times 10 to the 1 is actually 0.1. Times 10 to the negative 2 is 0.01. Negative 3 is 0.001. So as these numbers get smaller and smaller, the pH is getting bigger. And so once the numbers are really tiny, the pH is fairly large, which is why it's basic. So here's your neutral point. Anything above it, anything that's less than 7 is acidic. Anything that's greater than 7 is basic.